We have discussed that each function in JavaScript has prototype property and can be used as a constructor. And we discussed what happens under the hood when you call constructor function using new keyword plus function call. Let's now go on, and in the next example, let's add methods to the prototype. And it will be example 3. Okay, let me copy this part from previous example and paste it here and uncomment it. I don't need those console log statements. Let me remove them and let me delete this one and let me delete those statements. So, there is function declaration, civil plane, and it has props as single property, and inside of this function we modify this and add new property number of seats. Here we create new object that contains properties for small plane, and here on this line we create new instance of the civil plane and assign this new instance to the variable called small plane. Okay, let's now create one more instance of civil plane, and let's create large plane. So let's define properties for it, props for large plane, and it will have number of seats equal to 250. And here let's create new instance, large plane equal to new civil plane, and here will be props for large plane. Okay, let's save, and here I will be able to access large plane. It is instance of the civil plane and contains one own property, number of seats, that is equal to 250. Of course, it has also proto property that points to civil plane.prototype. We can check this here, large plane.proto equal to civil plane.prototype. And it is true. So now we have two instances of civil plane. First instance large plane and second instance small plane. Okay, let's now add method to this civil plane prototype. And let's suppose that we want to log to the console number of seats. For example, number of seats in the plane is and number of seats. Okay, let's first try following. I will add method directly here to this civil plane function constructor. Okay, this seats info equal to function without any parameters, and here inside of this function let's log to the console following string. I will use template literal, and here will be number of seats in the plane is $ curly braces this dot number of seats. Let's save this, and here let's access small plane. And let's expand this object. Now it has three own properties: number of seats, seats info, that is a function, and proto. Let's call this seats info function. Small plane dot seats info and function call. And here we get following string, number of seats in the plane is 4. And here we get undefined because this function doesn't have any return statement. Okay, let's call same function on the large plane object. Large plane dot seats info and function call. And here we get string, number of seats in the plane is 250. So behavior is correct. We take number of seats of each individual plane and log this string to the console. But it is something wrong here. How do you think what? This method is added to each instance of this prototype, and we have observed it here. So seats info is own method of this small plane object. Same with large plane. Let me access large plane here, expand it, and here you also see seats info method. It is not inherited from the prototype. It is own method for both objects. And it's not what we want to achieve. We want to add method of the prototype that will be available for every instance of this prototype. Okay, let me add comment to this example. Don't do this. Method will be added to every instance of the prototype. And this method is called here sysInfo. Let me copy it and paste here. Okay, let me copy this entire example, comment it here, and paste it here. And let me show you now how you should properly add methods to the prototype. Let me delete this part, and here I will do following. Let me cut it here, Command X or Control X, and here down below I will add this method to the prototype object of this civil plane function. So, civil plane dot prototype, and here I will paste cutted object. Of course, I need to delete this from here, and this new sysInfo method will be method of the prototype, and its contents will remain unchanged. Let's save this now, and let's access small plane now. If I will expand it, I will see now only two properties, number of seats and proto. If I will expand proto, I will see sysInfo method that sits here in the prototype, in the civil plane dot prototype. Let's now try to call this method. Small plane dot sysInfo and call. And here I get expected result. Number of seats in the plane is 4. Same with large plane. Let's call large plane dot sysInfo. And here we get this string. And that is the correct behavior. Now this method is inherited by all instances of the civil plane dot prototype. Let me add here comment. Correct. Method is added to the prototype. Okay, but how do you think what will happen if I will change this anonymous function expression to anonymous arrow function expression? Please try this yourself. Okay, let's do this now together. I will delete function keyword and add here fat arrow. Let's save, and here I will try to access small plane dot sysInfo and function call. I will get number of seats in the plane is undefined. Why is it so? How do you think? That's because this now, in this function, points to what? Points to window. Let's log to the console this. Let's save, and here let's call small plane dot sysInfo function call, and I get here window. That's because arrow function expressions don't have own this, and that's why they take this from the surrounding context, that is here in this case global object window. Okay, let me add here comment. Don't use arrow functions here, and let me copy this part, comment this entire section, and paste here correct option, and here will be function, and let me delete fat arrow, and let me delete this console log statement, and save. Okay, this is the correct way to create new method that will be available for each instance of the prototype. And here you should use a regular function. And when you will call this function like this, small plane dot sysInfo, then this inside of this function will refer to the object where this function was called. So in this case, small plane is this inside of this function. If I call this function on the large plane dot sysInfo, then this will be equal to large plane. Let me quickly add console log this back here, save, and call again small plane dot sysInfo, and you will see that this is small plane in this case. And if I call large plane dot sysInfo, this will refer to large plane here. Let me add here comment instance of the prototype. Okay, you can also create methods of the prototype that will perform some actions. And for example, they can change properties of specific instance of the prototype. Let's add one more method here. And let's add method that will change number of seats of specific instance. Let's do this here. Civil plane dot prototype dot modify seats number equal to function, and now this function will have one parameter, new seats quantity. And here inside of this function I will do following: this number of seats equal to new seats quantity. Let's now save this and verify if this method works. Let's first call seats_info, and here we will get form. Next, let's call modify seats number, and let's pass argument 10 to this function. Let's save this and let's try to access small plane dot seats_info again. And here I will get number of seats in the plane is 10. It means that this function has updated property of this small plane. Let me add here small plane dot seats_info, and now here we get 10. In fact, we get here strings, but for simplicity, let me leave here just numbers. I think you get an idea. So what happens here? In this function, modify seats number, we change value of the number of seats that is a property of this. You know that this refers here to the object where this function is called. And in this example, we call this function on the small plane object. That's why this inside of this function is equal to small object. You know that objects are reference types in JavaScript. That's why this and small object point to the same place in memory. That's why you can easily change any property of any object. And in this case, we change number of seats to new number of seats that is supplied as an argument when this function is called. Okay, let me add here a comment as well. Modifies property of the small plane. Okay, let's summarize what happens in this example. We have created two methods, seats_info and modify seats number. And those methods are methods of the prototype. And that's why they are inherited automatically by any instance of this prototype. And that is a prototypal inheritance in action. So this first function simply prints to the console this string, and here we access one of the properties of each instance where this function is called. And in this function, we modify property of specific instance of the prototype. It's possible because objects are reference types, and this points to specific instance of the prototype. Okay, I wanted to show you also that you can easily change any property of the instance directly. Let me clear console, and here you can change, for example, quantity of seats of small plane to 5. And now if I access small plane, here you will see that number of seats is 5. As you see, when you use prototypes in JavaScript, you have a lot of flexibility, and you can easily change properties of any instance directly or through the methods in the prototypes. Okay, let me comment this entire example, and let's move on to the next one. And in the next example, I would like to show you how you can create prototype of prototype. Remember that in the diagram, civil plane.prototype has its own prototype, airplane.prototype. So now in our example, prototype of civil plane is object.prototype. Let's now change this and let's add one more prototype, and it will be airplane.prototype. But before adding new prototype to the prototype chain using function constructors, we need to talk about one function, and it is object.create. Let's talk about it next. See you.